Hi guys, this is MIH. Pressure equalized dripping funnel is a common piece of apparatus in amateur labs. It has a glass or Teflon stopper to control the drip rate, and a side tube to equalize the pressure when the liquid is dripping down, which allows us to conveniently seal the whole apparatus when we want to add a liquid into a reaction. Besides adding liquid, some amateurs also use it as a separatory funnel and separate different phases of liquids, although the presence of the side tube makes the shaking and the venting steps slightly annoying to handle. But in fact, there are many more things you can do with this funnel, and in this video, I will show 4 ways you can use this piece of common apparatus to perform uncommon operations. The first use of the pressure equalized dripping funnel is as a traditional Dienstwerk apparatus, which is useful when removing water from reaction mixtures by azeotropic distillation. I won't get into how the apparatus works, as you can easily look it up online. I set up the apparatus as shown: a 3-necked flask with a hot plate at the bottom, the funnel in the middle, and a condenser on top. Note that I put a lab jack under the iron stand as the entire apparatus was too high, and some extra weights on the stand to keep it in balance. I measured out around 300 ml of xylene and added it through the condenser column. The xylene first filled the funnel, and the extra flowed down the side tube to the flask. I used xylene because I can't get toluene, but another organic solvent like cyclohexane also works, as long as the solvent is insoluble in water and forms a low boiling azeotrope with it. Then I added around 50 ml of water to the flask, along with 2 boiling chips. I turned the heat on and wait for everything to boil. After a while, vapor started to climb up the side tube, slowly but surely. Wrapping the side tube with aluminum foil will help considerably, but I didn't because I wanted to look good on camera. The vapors eventually reached the top, condensed, and dropped into the xylene in the funnel. The top of the xylene immediately became cloudy, as the vapors carried a portion of water over which was immiscible with the xylene. Over time, more water droplets formed and slowly sank to the bottom of the funnel, which I thought was mesmerizing to watch. Soon, a separate water layer can be seen gathering at the bottom of the funnel. Eventually, nearly all of the water in the xylene gathered in the funnel. As you can see, this approach of building an apparatus out of simple equipment to substitute the rarely used Dienstwerk apparatus is quite useful. Additionally, the dripping funnel is much larger than the water collection tube of the Dienstwerk apparatus, so it can store more water before it overfills. The only drawbacks of this apparatus are that the funnel needs to be pre-filled with organic solvent, and that the water removal process is rather slow. What is even more interesting is that the funnel could also be used as a heavy return Dienstwerk apparatus, which a traditional apparatus cannot do. An apparatus able to operate in both modes is very rare and expensive, but we can build one out of a cheap dripping funnel. To demonstrate this, I set up the exact same apparatus and add 60 ml of water into the flask, followed by 1 milliliter of 1 octanol. 1 octanol has a boiling point of around 200 C, which is just a little beyond this hot plate's temperature range, but it forms an azeotrope with water, so we can separate it in a fashion similar to steam distillation. Just like last time, the vapor slowly climbed up the side tube, eventually reached the top, and dripped down. Note that this time we don't need to pre-fill the funnel with solvents. After a while, we can see a small droplet of 1 octanol above the water layer in the funnel, indicating that we've successfully steam distilled and purified it. The bottom water layer can also be drained back into the flask, just like a heavy return Dienstwerk apparatus. Having a 2-in-1 apparatus is nice, but how about having a 3-in-1? In fact, the dripping funnel could also be used as a very compact, simple distillation setup that is especially useful when distilling dangerous liquids. To demonstrate this, I'll make the favorite element of home chemists, bromine. I again set up the same apparatus. In the flask, I have a mixture of sodium bromide, potassium permanganate, and water. I then pour some hydrochloric acid into the funnel. When the ice-cold cooling water is turned on and I was ready, I slowly dripped the acid into the flask, but judging by the tameness of the reaction, it can also be poured in. Orange bromine vapor is immediately formed, but overall the reaction is much milder than I imagined. I then turned the hot plate on and distilled off the bromine. As bromine is extremely volatile, it easily climbed up the side tube unlike the 2 previous demonstrations, and collected in the funnel. Because of bromine's extreme volatility, even if a very efficient condenser like this one is used along with ice-cold cooling water, some bromine will still escape, so some protection like a cotton ball soaked in sodium hydroxide must be used unless you have fume hood. Beside the bromine, some water also distilled over and floated above the bromine. You can remove this water by adding concentrated sulfuric acid in the funnel prior to the reaction. I continued to heat the mixture until I see almost no orange color in the flask. The bromine vapor was pushed into the funnel by the water vapor, which increased the yield. I used the bromine right away in the reaction, but if you want to store it, simply drain off the lower bromine layer into your collection vessel. The biggest advantage of this method is that no dangerous transfer steps are needed, so minimal bromine vapors leak out, and thus boosts both the safety and the yield. Other dangerous and/or volatile liquid can also be prepared in this fashion, like acetyl chloride or ethyl bromide. Finally, the last use of the dripping funnel is a Saucel extractor. I didn't have time to demonstrate the process, but Nerd Rage already posted a nice demonstration a few years ago with a lot of details, so I'm putting his clip over here just for convenience. He used a much smaller funnel, but the idea is basically the same. This again eliminates the need of buying an expensive and rarely used Saucel extractor. In conclusion, the pressure equalized dripping funnel can do much more than you think, acting as substitutes for a wide range of glassware like Deanstark apparatus and Saucel extractor, or vastly improving the safety for some dangerous preparations. Of course, using the funnel like this can still pose some problems. For example, the vapor might have a very high boiling point that it condenses in the side tube and cannot reach the condenser despite a lot of aluminum foil insulation, so these ways of using the funnel is only compatible with low boiling liquids. But still, this is so tremendously useful that I felt I must share with you guys as a great lab trick. I hope this video inspired you, and have fun in your experiments.